In this exam, we're given data on registered investment advisors headquartered in New York. These advisors are firms that manage money for individual and institutional clients. And these are annual filings. We have information on the date the filing was made, when the advisor first registered with the SEC, the SEC identification number, business name, city, legal form, assets under management, number of accounts, and some other things. First question, what is the unit of observation? So let's make sure we can connect to the data. So this is a text file. I downloaded it into my downloads folder, cleanadv.csv. And so we could see the SEC ID, it's a text, legal form is a text, city, state, date. It looks like a date is a date and time, or we could probably keep it. Number of offices, employees, SEC effective date, that all makes sense. Assets is a number, and so on. So this looks all good. Let's see how many observations do we have. We have 11,000 observations. What could the unit of observation be? Well, could it be a business name? Well, not quite. We see that some of the businesses have more than one observation. That's because we got annual filings. So let's see if we put in date. That's going to bring us closer to the number of observations. We see, let's see, this is 3i Corporation. They got one filing in each year, but it's not quite. The number of observations is 11,746, but we've got only 11,339 rows. So there are some combinations of business name and year that have more than 2 observations. I wonder if a name is not a unique identifier of a firm. So let's use the SEC number. Let's put that in front of the business name. And indeed, it looks like there are some business names that have more than one SEC number. So the unit of observation is really a business as identified by the SEC number and a year. That's question 1. Question 2, we're supposed to create a horizontal bar chart showing the top 6 advisors by their AUM in 2021. The length of each bar should show the advisor's AUM in 2021. Use color to differentiate between the legal forms of each advisor. So how will that work? So we could certainly see, we could put in a business name here. And probably to avoid those few that are not uniquely identified by business name, we could add the SEC number. We could use assets under management. So this is adding assets under management. Let's actually put it on columns because we're going to be using a horizontal bar chart. We could certainly sort it. We could see JP Morgan has got the most assets. Keep in mind, this is adding it across all the years. So let's show filter, and let's filter it out to only 2021. And now here we can actually see who the top advisors are in 2021. And we're going to create a set to identify those top 6 advisors. So let's highlight these top 6. Is that 6? 1, 2, 3, 4, 5, 6, 7. Okay, we got 7. Well, we're going to exclude one of them. It's going to create a set. We can, I think it's the last one. We're going to get rid of Morgan Stanley. X that out. So we get just these 6 businesses, and these are the top 6. We're going to call it top 6 in 2021. Okay. Very good. We can add that as our filter, keep only those guys. We can add a legal form to color, and these are the top 6 advisors in 2021. Why did we have to use a set instead of using a condition filter? Because the condition filter would filter out top advisors by the sum or by the average of their assets across all 10 years. And we only wanted to have a top 6 in 2021. So in this case, we had to use a set. That's question 2. Let's see, in question 3, we're supposed to know what's the value of assets in a typical account. So each advisor, each firm manages several accounts. If you want to know what's the value in a typical account, we need really assets, total assets divided by the number of accounts. And then we want to do an annual time plot showing the average of assets per account in each year. So we're going to have to create a new calculated field, and we're going to call it AUM per account, which is going to be just AUM divided by number of accounts. Fantastic. We can put that on rows. We can put date on columns. Let's make it continuous by year. And we don't want the sum of AUM per account across all advisors. We want the average AUM per account. So we're going to change the method of aggregation to average. And so we see that on average, assets per account is pretty high. Very wealthy clients, looking at 108 million, 160 million, and overall it has gone up. And so this is averaging across, roughly, I don't know, couple, like 2,000 advisors across in each year. Actually see how many advisors we have in each year. Let's just put a quick label here. Yeah, about 1,000 advisors in New York. That's the number of advisors headquartered in New York State. So that's question 3. In question 4, we're supposed to duplicate a sheet from the previous question and add a line showing aggregate AUM per account. So yes, I'll do that. I'll duplicate that sheet. Make sure I'll rename this, call it Q4. And I'm supposed to add aggregate assets per account because here I'm plotting average assets per account. But of course, this could be biased. This could be driven by a few advisors that manage really, really wealthy people. So if I want to know what is really a typical value of assets per account, I need to calculate aggregate assets per account. So I'm going to call it aggregate AUM per account, and it's just going to be sum of AUM divided by the sum of number of accounts. And I'll close it, and we're going to say okay to that, and let's plot it. Let's put them on the same in the same graph. So we're going to use a dual axis. Let's not actually synchronize the axis because it would make one of these lines look really, really small. So we can actually keep the lines on 2 different scales. The blue one, that's the original one. That's the one that ranges in hundreds of millions, around between 100 and 160 million. The aggregate AUM per account is much lower. It's about 2 million. So clearly, there are some advisors that have very, very high assets per account, but a normal, a more typical amount is around 2 million per account. And we actually, interestingly, we see that that didn't increase. That seemed pretty flat. So it looks like the growth in assets per account happened at the high end among the wealthiest, highest, most valued accounts. Okay, so that's looking at typical values of assets per account. In question 5, let's take a look. We have to create a dimension that consolidates the 4 least numerous, in terms of number of observations, categories of legal form. So how do we do that? So I'm going to call this Q5, and let's see. So legal form, let's examine how many observations we've got in each legal form. Let's actually even sort them. So clearly most companies are limited liability companies. Most advisors are limited liability companies. There's some corporations, limited partnerships, and there are these other and sole proprietorship partnerships and limited liability partnerships. And we're supposed to consolidate these least numerous one, right? Because they're really so much smaller than the top 3. We don't want to have, when we want to compare things across legal form, we want to have more consolidated categories, fewer categories. How can we do that? Well, group is a really good way of consolidating dimensions. And so we're going to say group, and we're going to put sole proprietorship, partnership, and then other. We're going to group these guys into other. Oops. All right. Sure, we can leave it like that. And I see there's one more. So we got a limited liability partnership also needs to be added to that group. So we can actually drag it there. And now we have, what do we have? We have this more consolidated dimension, this grouped dimension. Let's see, does that work? Let me actually change the name of that consolidated category. I'm just going to call it rename. I'm going to call it other. Why not? Why can I call it other? All right, we'll call it other 2. All right, fantastic. And so we can see that now we have these 4 categories of the legal form: corporations, limited liability, limited partnership, and other, which consists of 4 very small categories. If we want to add up the number of observations we have in here, we could do totals. Let's just do here, add all subtotals. You could see 284. 284 of these small advisors or observations that belong to those 4 least numerous legal categories. All right, fantastic. So in the next question, we're supposed to see the share of assets by the consolidated legal form, so 4 lines, and the height of each line showing the legal form's share in total assets in each year. So how will that work? So we know that we need assets. That's going to be the height of each line. We know that we want year to be on the horizontal axis because we want that a time plot. We want it to be differentiated by legal form, not this legal form, but the grouped legal form. So that we just have 4 lines. Now, of course, this is showing us total assets. We know that total assets went up, but I want to know whose share of assets in each year went up or down. And the hint tells us that we could use a table calculation for that. And there's a really useful table calculation for that, which is a percent of total. And we want to calculate percent of total across legal forms for each year, not across years. So this way, if I say table down, I'm really looking at each legal form's share in each year. And let's see if that actually makes sense. So here we've got corporations. In 2012, they had 42%. These guys had about 38%. And so 42 plus 38, that's about 80. And so these two should then combine to about 20, and they do. Right? So essentially, the sum of these 4 lines should always add up to 100. And what do we see? Whose share actually declined? Clearly, the other categories became less popular. Limited liability companies, they gained assets. Corporations, their asset share actually declined, and limited partnerships also increased to 19% from about 13%. So that's our question. I think that was question 6. Fantastic. Let's go to question 7. Using the number of years since the initial SEC registration as a measure of age, create a scatter plot that would show the relationship between company age and AUM in 2021. So we need to create age. How do we create age? Let's say we got age. Well, today is 2022 minus the year of the SEC effective date, the year of the original registration. It's going to give us age, and we want to let's put age on rows, and let's put assets on columns, and let's put business name and SEC number on detail. Let's limit this to just 2021, as the question asks us to do. And clearly, this graph is really dominated by companies like JP Morgan, Goldman Sachs, that have lots of assets, and there are these much smaller advisors. Let's see if we could fix that by making the axis logarithmic on this end. And let's actually flip the rows and columns, and there's really very little correlation between age and assets. But if there is anything, I would say it's positive. Certainly the bigger firms tend to have a little more assets, but the relationship is definitely quite weak. We could probably edit this axis and the bottom, instead of having it start at 1, let's start at 10 million, about 10 million. Yeah, it's still is pretty unclear relationship between age and assets. So very weak relationship between age of the firm and assets that they manage in 2021. Fantastic. 8. Suppose we're interested in the number of small advisors in each city in 2021. Small advisors are those with annual AUM below 500 million. Create a horizontal bar chart showing the number of these small advisors in each city in 2021. So how can we do that? So we know for sure that we're going to be looking at just small advisors. And so we could certainly create a dimension for small advisors and just filter out big advisors. We could also use a row level filter. So let's go that route. Let's put AUM under filter, and let's select all values, because we want to use, we want to eliminate every year and advisor that has less than 500 million. So we're gonna cap this at 500 million. I'll say okay to that. And I want cities. So where do we have a city? So here's a city, and I want to count how many advisors there are. Actually, I want to make it into a bar chart, so I'll go up here and I'm gonna sort it. Clearly, New York City has the largest number of observations on small advisors, and keep in mind that this is adding advisors across all 10 years. So I need to put in an additional filter and keep this only to 2021. And so in 2021, there are 207 small advisors in New York City, 24 in Rochester, and so on. And we're also asked to include a filter that would show only cities that have at least 10 advisors. So Williamsville will be included, but Syracuse shouldn't. So this is another filter, but this one, this is an aggregate filter, summary filter, rather than a record level filter. And it's going to be on the number of observations. So I'm gonna put it. Oops. I'm going to drag it to the filter card, and I want to show only cities that have at least 10 of these advisors, and that's what I see. Clearly, Williamsville is in there, but Syracuse is no longer there. Fantastic. So this was question 8. Now, in question 9, we're supposed to add some data. We've got some data on the S&P 500 that has the end of the year value of the S&P 500 index, measure of stock prices, and we're supposed to join this data with our advisor data so that the end of the year values of the S&P line up with the years of the advisor filing. So because we see that advisors file throughout the year, they don't all file at the end of the year. So the date of the advisor filing is not going to match with the last trading day of each year, because that's what we've got in the S&P 500. So let's see how that would work. We're going to go back to the data source. We're going to add a connection to S&P 500 CSV. We're going to open this data source and link it with, I have to find lots of things in my downloads folder. There's a S&P 500. Link it with the advisor data. And we're going to wait a little bit. So right now we don't have any matches at all. Clearly, we actually hasn't even determined how the data should be matched. But we know that essentially both data sets have annual time frequency. We've got one filing per year, even though the dates are different, but we want to extract year from date in the advisor data set. And that should be lined up with year of date in the S&P 500 data set. So let's see if that actually works. So we'll wait for the preview and so here is a filing from 2021. This firm, what's the name? This is JP Morgan. All right, and they filed in November 2021, but it's linked with the S&P 500 value from December 31st of 2021, which is 4,766. If we scroll down, let's see if we get another, let's go maybe 200. If we have 1,000, so it's going to take a long time to scroll through this, but it looks like we matched the data correctly. Let's take a look how many observations we have. So I used inner join, but that's okay because it looks like all the years that we have in the advisor data are also contained in the S&P 500 data. And if the S&P 500 data had some extra years in it, we don't want them because we're really focused on the advisor data. Fantastic. So what are we supposed to do? We're supposed to join the two data sets. It looks like we did that successfully. And we're supposed to see a time plot of annual aggregate AUM and the S&P 500 in one graph. So let's do that. We're going to put up a date. Let's make that continuous year. We're going to put AUM on rows, and we're going to put the S&P 500 value also on rows. Now we want aggregate AUM for each year. That makes sense, but so we're using the sum as the method of aggregation. But for the S&P 500, what are the values here that says 2 million? Well, S&P 500 was not 2 million in 2012, and it wasn't 6 million in 2012. We're just adding the index across all advisors. We have 1,000 advisors in each year, so we're really multiplying the index 1,000 times. And the advisors, the number of advisors in each year is not the same. So sometimes it's multiplied by 1,000, sometimes it's multiplied by 1,100, and we don't want that. We want to plot the value of the index. So instead of sum, let's use, we could use median. It's going to give us the same result. Actually, I'm going to get rid of this count field. It's going to give us the same result here. This is the median of the S&P 500 is about 4,766, which is the value of the S&P 500 at the end of 2021. Let's put them on dual axis. Of course, they're in totally different scales. We're going to keep these scales different. And we see quite nicely that AUM has gone up and the S&P 500 has gone up. And in fact, we see that the S&P 500 went up a little steeper than AUM. So S&P 500 went up faster than overall assets under management of these advisors. And in question 10, admittedly a challenging question, we are asked to create a chart that would make this very clear, that would essentially rescale these two measures in such a way that they would all start at 100, and we could see then how they evolve relative to each other if they start from a common point. So this is similar to what we did with the CPI index. We just need to rescale each of these measures by their initial, by what we can call the base year value. And for the S&P 500, that is 1,426. And for the AUM, aggregate AUM, oh dear, it's a really big number, 9,665,701. 629,202. All right, so I just wrote this down on a piece of paper, and let me create two new measures, two new calculated fields. I'm going to call this AUM index, and I will make that basically AUM divided by 9,665,701 629,202. And let's multiply it by 100 so that it shows up as 100. I'll say okay to that. And let's actually, what we'll do, we'll duplicate this sheet. I'll call this, this is a question 10. And we're going to replace AUM, sum of AUM with the sum of AUM index. And indeed, we see that the AUM index starts at 100. And then we're going to get rid of these other guys. And we're going to create now the S&P 500 index. So we'll call SP 500 index, which is SP 500 divided by 1426 times 100, and it's going to be okay. And we'll have to we'll put them on dual axis. We'll change this, sure, we'll change it to median again, put it on dual axis, and we'll synchronize the axes. We can get rid of the header on this side. We can extend this axis so that we have space for labels. So this one, let's extend it to 2023. And that way we can put a nice label of actually don't need measure names. Let's put measure names on label. Okay, and we can put measure names on color too. And so here, this is the S&P 500 going up at a much faster rate than the AUM. So S&P 500 outpaced the assets that these registered investment advisors manage. They fell behind the assets. And that's it.